So this talk is about using Bluetooth Low Energy for indoor location positioning. So these are the beacons that I'm used to using. They're called Estimotes. I've used them in the past, and they're really easy to work with. I contacted Estimote to see if they could give me anything to give away. They gave me 3 developer kits to give out, and I've been struggling all week to figure out who to give them to. They said to give them to people who will actually use them. I think they cost about $100 a piece. Yeah. We're like 1 beacon short of giving one to everybody. There's 3 in a box. So, I know we can talk more about this after the talk. What I was thinking about doing was, if you have an idea to actually use these things, send me a tweet, and if I think your idea is cool, the top 3 ideas where I think you'll actually implement something, I'll contact you and you can come pick them up. Sound all right? Cool. All right. So throughout the talk, I should put my Twitter handle up. I realized I don't have an About Me slide, so I'm just an Android developer. That's all you need to know. My Twitter handle, if you want to tweet during the talk or to send me an idea. So that's me at Brent_Watson. If you have any questions, go ahead and yeah. All right, we'll jump into it. So, we said we're using iBeacons for indoor location positioning. We're going to use Estimotes. I'm going to show some code 2 ways. One is using the Estimote API, and another one using the built-in Android Bluetooth package. So we'll see native, and we'll see the nice wrapper around it that Estimote gives you, and most beacon providers have something for you to use. There are many competitors, Estimote, many people making Bluetooth beacons. These are some of the options you can have. There are others that are less developer friendly. If you were having a giant rollout where you need thousands, there are companies that sell them at that sort of scale. The ones I listed here are popular because they're the ones that are focused on developers. So if you're a developer, you want to get started quick, just take a look at these guys. Estimote's good. They have an office in New York. So, getting support from them, getting things shipped is pretty fast. These guys are good too. I've played with Stick and Find, and they're also very easy to use. All right. So, what is an iBeacon? So, I'll show you what they look like here. It's a little thing with a sticky back, and stick them on a wall. Inside here, there's a CPU, a little 32-bit ARM processor, some flash memory. These ones have a built-in accelerometer and temperature sensor. I put an asterisk beside them because the Android SDK doesn't give you access to those 2 things yet. The iOS SDK for these, they just added it. So Android should be coming soon. Of course, we always play second fiddle. And the most important thing is the 2.4 gigahertz Bluetooth Smart. So, which is the worst name ever, Bluetooth Smart. So, it was the marketing department tried to come up with something catchy and failed miserably. Yeah. So, most people call it Bluetooth Low Energy. I'll just say BLE for the sake of consistency in the talk. So this is what they look like. I tore one of these things open, so pass it around, you guys can. So the actual ones are like sealed. You can't even get into them. You have to chop into them. You can see why that is in some upcoming slides. So this is what they look like. You'll see that most of it is just like casing. The actual thing's pretty small. Like if you were to chop off the edges of it, it's about the size of a postage stamp. The battery takes up a lot of room. Like the important bits are just the RF chip on here, which is the Bluetooth chip. They also highlight this other chip in there. I got this right from the Estimote site. I think that chip number is the accelerometer. All right. So this is what makes Bluetooth Low Energy like super awesome. All right. So Nokia started building on the Bluetooth Low Energy spec in 2004, and they snuck it into the 4.0 spec for Bluetooth Low Energy, which means that any new phone that says it supports Bluetooth 4.0 has to support Bluetooth Low Energy. So it was cool that they snuck it in because it means that it's just everything. Like you get it for free. You know, there are Bluetooth Low Energy devices that aren't Bluetooth 4.0 compatible. But if you say you support Bluetooth 4.0, you must support Bluetooth Low Energy. So even like the new Android One phones that are coming out, the cheap phones, will support Bluetooth Low Energy. It's pretty cool. The next 2 points, the 2-second pairing and no dongle required are a big one. So pairing it with old Bluetooth is a pain in the butt, right? I don't know who's tried like on the old phones where you had to like actually enter a code for your devices, or you have to plug a dongle into your computer. All that goes away with BLE. The fact that you can pair in 2 seconds is pretty awesome as well. I put down here that it also fits into the 2.4 gigahertz spectrum. And so like Wi-Fi happens at that range too. And unlike Wi-Fi, where you usually only pair to one thing, you can pair to dozens and dozens of Bluetooth Low Energy devices at the same time. So this, like the spec is very well done. It actually has very little in common with actual Bluetooth, other than things like it can compare and send data. So if you've used like similar like sort of communication dongles like this, they're probably something like a Zigbee with Bluetooth Low Energy. Message delivery is guaranteed, as where with Zigbee, you might get some of the bytes. You have to see if you get the full message length. It's actually a little bit complicated. These things can be sealed up because the battery life is so great. That's the other thing. The other things in the 2.4 gigahertz band are usually very battery intensive, right? If you've ever tried to run like a MiFi on a battery, it's dead in like a few hours, right? So here's a graph showing expected battery life on these things. So you can adjust the advertising interval, so you can have it happen very fast, or at the top of this graph they show 2 seconds, so it'll send a chirp every 2 seconds. And you can change the broadcasting power, which is just like the range that the signal will actually go. So if you're okay with only sending a chirp like very infrequently for a small range, something like this can last 3 years. So the thought is they're actually sort of disposable, right? Instead of changing the battery, you're just going to pluck it off the wall, put up a new one, and do that. They're very cost effective. So these developer kits are, like I said, they're $90 to $100. So these beacons are about $30, but at scale, if you have a big deployment of them, you're actually probably looking at around $10 per beacon. It has better distance than Bluetooth, even though it has lower energy requirements. Like I said, it fits into the 2.4 gigahertz spectrum, and I won't get too in depth about how this works, but it's neat. If you look at the graph for Wi-Fi signals, it's sort of like a wave, right? And the channels that Bluetooth Low Energy operates in is like at the values of those channels. So just by picking where they broadcast, even at a conference like this where everybody's phone has Wi-Fi turned on, there's probably a dozen Wi-Fi networks in range, that channel is just white noise right now. But these things will still work perfectly fine, even in all that white noise, just because of how they've assigned the BLE spec. I also put here that they're more practical than NFC. So now that we have NFC in watches, that's going to make it a little bit better, but not everybody has a watch. So right now, where NFC works great for a payment system, where I want to buy my coffee, I take my phone out of my pocket, I touch it to a thing, it beeps, transaction's done. That's great. But it doesn't work for turning on lights when you enter a room, right? If you want to do that, NFC is very point of contact, right? Small range, need line of sight. So I'm not going to walk up to a light switch and touch my phone to it, because I might as well just flick on the light switch, right? Given the range of these things, there's a lot more applications for them. There's a really good talk on YouTube if you're interested in more about these things and how they operate at a lower level. There's this talk on YouTube by a guy named Mark Colley called The Real Power of BLE, and he starts the talk by saying that he thinks these things are more important than USB. That's sort of where they'll go. Where USB took technology, these things could be the next thing. I think that's actually probably a little too far-reaching, but given just that's what somebody said, means there's a lot of potential here, right? All right. Before we jump into some code, I'll explain maybe one example situation where these could be used, and it's the common example that everybody uses. So if you took BLE sensor and put it by every department in a retail store. So you have, let's say you have 3 floors. First floor you put one by the shoe department, the other one by the coat department, one by the bathrooms. The second floor you put one by the cat litter department. One by every department. And then when somebody walked into that store with their phone, they opened up that app, you know exactly where they are. So you know the distance they are from each of these beacons. That's really what they give you, is the distance to them. So you could open up the app, be like, you just enter the store, I want to get to, men's coats. Okay, it's that direction, I'm currently here, go this way. Oh, it's 2 floors up, have to go up an escalator, which is this way, etc. So it's all about finding static points in a building. Another good way to think about it is that these things sort of fill the gap where GPS falls down. So GPS doesn't work well indoors, GPS doesn't work well underground. That's where you can use these things to actually get position data. All right. So far at this Android conference, I haven't seen any code, which saddened me. So I'm glad to say about half my talk is actual code. So we'll we'll see how this goes, because live coding has its challenges. Let that start up. And while that's starting up, one other point is that you think about this in a weird way, because you're like, this little thing actually acts like a server because it's sending you data, and your phone is a client. We're not going to get into it. You can switch those roles so that you can send updates to these. That's a little advanced for a 40-minute talk, but so for our intents and purposes, your phone's a client. This thing is a server. All right. At the end, I'm going to post the link. The slides are online for you guys, and all the code is on GitHub, so don't feel like you have to make notes about the code. That's all available. Okay. Also in the code, when you guys grab the code, it's broken into 4 parts, or 4 projects that are the 4 different parts of the talk. So I have an app called Part 1 to Part 4, and each one of those has a README file. It has a README that just says, here's what you have to do in order to get to the point that the project is already at, in case you want to know what the steps were. I'll go through these. Okay, so part 1 is to grab the Estimote SDK, just a jar file you plop into your project, add it right here. And then number 2 is manifest. So in your Android manifest, you have to add your Bluetooth permissions. You have to add Android permission.bluetooth and Bluetooth admin. Bluetooth admin sounds weird, but almost all Bluetooth applications have it, because without it, you can't activate device discovery, which makes it pretty much useless. So you have those 2 Bluetooth permissions. My activity in all of these things is very basic. It shows pretty much nothing text, so just an empty screen. We're not talking about how to build an Android app, so we're just going to log everything. We're just going to use Logcat to see the data that you're getting from these things. And then the last thing is you start up this beacon service, which is part of the Estimote SDK. So that's running in the background, doing all the cool Bluetooth low energy stuff for you. All right, and here's the good stuff. All right. So there's a couple classes that we're using from the SDK, Beacon, Beacon Manager, and Region. So I'll start at the top here. So we're going to make a region object. We're going to pass in this Estimote proximity UUID, which is just a universal unique ID, big long string. And this is the region that we're going to look for Estimotes within. So we're passing that UUID in here. Every single Estimote SDK that's built has the same UUID. So your dev kit has the exact same UUID as your dev kit. Every Estimote in the world has the same UUID. So to find all Estimotes built by Estimote, you can use that UUID. So right now, we're taking a look for all of them. These things also broadcast a major number and a minor number. And those you can change yourself. So these null spots are for major and minor. So I'll get back to that in a second. Alright. So when the class starts up, we get an instance of Beacon Manager. I'll start at the bottom. So on destroy, As beacon manager, you're just going to disconnect the service. When the activity stops, you're going to stop ranging for all your beacons. It's pretty basic with some exception handling around it. When it starts up, you're going to start ranging for all S-mode beacons and some exception handling. And that's all pretty trivial, right? That's just boilerplate code. So the only thing left is on create. So this is where the magic happens. So that beacon manager, by the time you get here, all of the initialization stuff is done for it. And you call a method called set ranging listener. You pass in that beacon manager.ranging listener object. It has one method, on beacons discovered, and you get a list of beacons. So we'll run this and see what it looks like. I have a bunch of beacons here. I'll actually put them throughout the room so that the ranges are a little different. I'm going to run this thing. So it's running every, this is actually going to, that method's going to execute every time that it goes and discovers beacons. So it's going to come up again here. And I'm just printing out the list. So we can see some, I'm going to stop this. Actually, this log pad up here looks a little bit nicer. Kill this guy. All right. So you can see we're getting a list of beacons. Every single one has the same estimate UUID, and then they have different major and minor numbers. So this one's major and minor is this, and then you get the power and RSSI, which is the signal strength. And then here's the next one. So same UUID, different major, different minor. So if I want to grab just this beacon up here, I can change that. So again, it's the UUID, the major, the minor. So I've put in a major number, so I should only get back that one beacon. I should have mentioned the first thing that I had logged here. So on beacons discovered, the first thing was the size, and then I printed out the list. So now I'm getting back 1. Before I was getting back 19. And there must be other estimates in the building. Yes. It's interesting. Maybe we can track them down later. Find out where they go. All right, so here's the one beacon. So I mentioned like the retail store before, and again, major and minor are programmable. You can change them. So you could, for example, you could set the major number to the floor you're on, right? So I could range for all beacons with the number 1 if I'm on floor 1, or just all SMO beacons. If I get back to 1, I know they're on floor 1, 2 for floor 2, etc. And then the minor number could be like the department. So I know what floor, and then based on the minor number, I know what department you're in. All right. So instead of just printing out the beacons, let's see what you can get from them. here's what you have available. There's get major, get minor, get MAC address, get the UUID, so that's all great. Name would just say Eskimo. And as you can see, there's no like, sorry guys. You can see there's no .get distance method, right? And that's really what we're interested in, is the distance for these things. The two things that it does give you is the measured power and the signal strength. So using those two things, you can calculate distance. So you don't have to do it yourself. Estimo gives you this utils class. And it's got a bunch of methods in it. The two we're going to be worried about is compute proximity and compute accuracy. So if we call compute proximity, that's the beacon. So this is actually going to give us one of a set of enums. It's either going to say unknown, immediate, near, or far. So let's see how that works here. So I don't actually know which one that number is, but apparently it's close to me, which seems about right. If we did this for all of them, they'd be different, right? Some would say near, some would say far, some would say intermediate. So that's useful. That's like an easy way to know if you walked up to one, it'll say immediate. Would you let me quote them all? Well, yeah, I'll leave more there. So, that's a nice little utility function. Instead of that, we can also do utils compute accuracy. So the accuracy will give you the distance in meters that you are from the beacon. Sorry, let me get rid of this restriction. So that only took us a few minutes, and we're actually getting something that's very, very usable, right? To me, that's pretty cool. When the guy said, like, this could be as big as USB, I think this is why, right? It's not that hard, and this data is something that other pieces of tech can't do. Yeah, to me, that's really awesome. So I think we've covered part 1 and part 2. So if you were to grab this code, we started with part 1. What we ended up with is essentially what I would have done in part 2, which is just showing the proximity and the meters. Up next is going to be part 3. Let's see if I have anything else in my presentation here first. I think I only have about 5 minutes left, so we'll zip through it fairly quick too. Oh, this is handy. If you're actually going to do anything with these things, just take a snapshot of this code with your phone. You can check to see if your device supports Bluetooth Low Energy with the first bit of code. It's pretty easy. And then you can check to see if Bluetooth is turned on. So on your phone, you can't actually toggle Bluetooth versus Bluetooth Low Energy. It's either Bluetooth is on or off. So the first one, make sure it's supported, and the second one, make sure Bluetooth is turned on. And if it's off, it'll pop up a dialog asking you to turn it on. So that's all built into the Android .Bluetooth package. It's very useful. So this Android.Bluetooth package, I probably won't have time to run this code if we want to get through it all, so I'll show it off. Okay, so first up, you'll see there's no libraries. I don't have to include anything. What I do have to do, though, is the Android.Bluetooth stuff only supports low energy devices for SDK 18 and up. It's 4.3. Okay, so how this works, we're using a couple Android.Bluetooth classes, a Bluetooth adapter device, which is a beacon, and a Bluetooth manager. You start by getting the Bluetooth manager, and the only thing you use that for is to get a Bluetooth adapter. So the adapter only has a few low energy. Sorry, let me make this bigger. Okay. So the Bluetooth adapter, again, works for everything Bluetooth related. So there's a lot of stuff in there, but there's only a couple low energy methods. One is called start low energy scan. There's another one, stop low energy scan. Start scan is overridden with taking a set of UUIDs and then always takes a callback. So I've made this class implement LE scan callback, which is just on low energy scan. And you get it in the device, you get it in the signal strength, you get it in the scan record. So if we were to run this, we would be able to print out the UUIDs, get the MAC address, etc. So I ran this expecting to get, this is where I'm going to throw Estimate under the bus. I ran this expecting to get the same data that I got before, and I don't. The UUID is always null. The major and minor versions are always the exact same number. The device name always says Estimate. I thought that was strange, so I decompiled their jar file that they gave me, and all of that stuff they bundled into this scan record byte array that they give you. Which means that if you choose to use estimates, you're probably not going to switch to another Bluetooth Low Energy device because they've made something very custom. So part 4 of the code examples. If anybody's interested in taking a look at it, I made a class called Crazy Estimate Utils, which actually decodes all that stuff, and it's actually quite it's pretty involved. You have to take the byte array record, decode it as hex record from your set of bytes, which is also fairly complicated. You have to go through that scan record and decode everything and wait for specific records to occur. And some of these make sense, like the proximity UID that you find is just the hex at these two locations and then a dash, and then 26 to 30 and then 30 to 34. That makes sense. But like the major number is one hex code at a specific location times by a constant plus hex code at another location. So again, this is very shifting. What's that?
Bit shifting.
Yeah. So again, it's this isn't a common thing. I don't know why they did this. Maybe they have their reasons. All right. Let's wrap this up. So I'm excited about this technology because the market's really young and it's really easy. That's like the perfect recipe for making a startup. Like two quick ideas would be something like you get off an airplane, you open up your phone, and it tells you exactly where your gate is that you're trying to get to. Another one would be like you go into a casino, you order a drink at one table, and they know what table you're sitting at. So if you switch tables, your drink will eventually make it to you. Etc. There's a million ideas you can come up with. It's on all new phones. Here's the list of older phones that it supports. Going forward, so every new device supports Bluetooth Low Energy. I expect beacons to be easily under $10. They're going to get smaller, the battery life will be better. I think the tools and the SDKs will be better and hopefully get more standardized. And this idea of like the Internet of Things will be, I think this will be a big part of them. Grumpy Cat, who's the authoritative figure on Bluetooth Low Energy, tells us that video and audio is a big no. The bandwidth just doesn't make sense. All right, I think that's it. Here's a link to the code if you want it, and a link to the slides. I thought I had my Twitter handle on here too. Oh, I do. Didn't show up. Alright. So, again, I have 3 developer kits to give out. If you would like one, send me a tweet that says what your project idea is with Bluetooth Low Energy. I'll pick the top 3 ideas and contact you to pick up your beacons probably tomorrow. That's it. Thanks for coming.